Hi everyone, welcome to the lesson 6 of topic 2, Kinematics of Motions in Straight Line. So this is also our last lesson. So as mentioned in the previous lesson, right, we talked about how to use differentiation to help us to solve the problems which we do not have a fixed acceleration, which means that the acceleration is not constant. So for today, we are going to look at another part, which is how to use integration to help us to solve the similar question. Alright, so same thing, the integration skills that you are required is only the techniques from P1 only. Alright, so we'll try to do some recap on that. Then after that, we'll move into the introduction. Alright, let's start with the recap. So yeah, these are the things that we learned about integration in Pure Maths 1. So basically, there are only two main techniques that we have. The first one is how to integrate x to the power of n. So I guess this one you all should be quite familiar with it. So which is power plus 1 and you divide by the power, right? So n plus 1, then 1 over n plus 1, and then x, and then power plus 1. Okay, so this is indefinite, which means that you do not have a limit for this integration. So that's why you must remember you need to plus a constant. Alright, so for this case, it's similar like the composite function that we have in differentiation, but in integration case, we are going to look at the linear expression only. Okay, so you can try to imagine if let's say we have y equal to ax plus b to the power of n. If let's say I want to do differentiation, then what happened? I'll try to bring the power in front, right? Then after that, ax plus b, and then power n minus 1, and then multiply the derivative for ax plus b, which is a. Okay, so we try to imagine by doing the same thing here, but then our general thing here is that the power plus 1 and we divide by the power. So what happened here is I have 1 over then n plus 1 also. Okay, then after that I'll just copy exactly the same thing, which is ax plus b, then power is n plus 1. So for integration, we multiply the derivative. So for differentiation, we multiply the derivative. So for integration, we will divide the derivative, which is we have a here. Okay, so this is under divide also, then plus c. Alright, so that's the only two techniques here. Then after that, we also know some rules that actually help us to simplify our integration. So the first one is if let's say we have a constant together, multiply together with the function. So what we can try to do is we can try to take out the k, right? So k, and then you can just integrate the function with respect to x. Okay, where you must make sure that your k must be a constant. So which means it cannot be any expression that involve any unknown there. Okay, sorry, involve any variable there. Alright, then the second one is if let's say you have two functions inside the integral, then meaning that what we can try to do is we can actually split them out. So meaning that I can do f of x, okay, with respect to dx, and then plus minus integrate gx with respect to x. Okay, so which means instead of like doing them together, it's just basically split them up and then do it as normal, like how we solve with a single expression. Okay, then after that, this is for the finite integration, which means that we are going to be given a limit. Okay, so if let's say when we try to integrate the function of f of x with respect to x, we are going to get this answer. This is our integral. So which means that when we have this limit, then what's going to happen is we'll try to write it in a box, right? So this is what we get from the integration. Then we are going to substitute the lower limit and the upper limit, so from a to b. So which means our answer will be the upper limit when we substitute. So we get fb then minus fa. Alright, so this is from A to B. So that's why I use the bigger one to minus the smaller one. Alright, so we use like the n to minus the beginning. Okay, so this one is the similar like the constant here. So it's just that it's in the finite integration. So which means we are just going to take out the k lah. So take out the k, then everything stays the same. So f of x plus dx. Alright, so because this is the finite integration, so we doesn't have a plus c here. Okay, am I? Oh yeah. Okay. Alright, then after that, the third one. So this is the similar like the previous one. So if let's say it's splitted up and then you have okay, which means that you are having two integral that with the same limit, then we can always try to combine them together. So the relationship is actually vice versa. So which means that you can split them up if let's say that's easier, or you can just combine them in that if that's easier. So it means it can go from here to here or even here to here. So that's why this is the form where we, from the splitted form, we try to combine them together. So you must make sure that their limit is the same, then only you can combine them, all right? So we have a to b, okay, then after that f of x plus or minus gx dx. Okay, then after that, the next one we are talking about how do we try to change if let's say we have a to b, right? If we want to change it to b to a, can we do that? Yeah, so you will just negative the integral. Okay, so I hope that you still remember this because this is very important for your P3. Okay, so now let's try to look at this last part. Okay, so for the if you can remember, right, for application for integration, we actually learn about the area under the graph and also the volume. But in M1, we are just going to use area under the graph, and also is basically only the curve and the x-axis only. Because later you will see when we try to look at the displacement time graph and the velocity time graph, right? The area under the graph is basically the area between the line that you have and the x-axis. So we wouldn't have any case where you need to do with respect to y. Okay, so that's why this is the one that we are going to revise on. Okay, so this is the area that bounded by the curve y equals to f of x, the x-axis, all right, the line x equals to a and the line x equals to b. So when we want to find this area here, so which means we'll try to do a will be equal to, so you can just remember the lower limit to the upper limit, so which means from a to b. So this is the graph and the x-axis, right? So you can just remember dx here. So if you write dx here, meaning you are going to substitute y here, so that later when you try to substitute your function here, you are having a variable which is x that you can actually integrate. All right, so it's a similar thing if let's say I try to write in f of x. All right, so yeah, so that we can integrate the x here. Okay, so very simple notes here is that you must remember, like, if let's say you have an area under the x-axis, right, that will give you a negative answer. So you must be very careful that, especially if let's say you are finding displacement, so the positive or negative, it matters, right? So that's why you must make sure that you are giving a correct answer. Okay, so yeah, that's the part for the recap. So now let's look at the introduction for this lesson. Alright, so for the concept today, we are going to use two ideas to actually help us to understand. So the first one is simple, that we understand that integration is basically the opposite operation for differentiation. So that's why we try to use this relationship to come up with the diagram. Then you will know how to answer everything. Then the second thing is we try to answer it as the part where we know that for a velocity time graph, we are using the area under the graph to actually help us to find displacement. So that's why we understand that one of the application for integration is actually to find the area under the graph. So by using this idea, we can understand why we need to do the integration in this case. All right, so let's start with the first one. I think this is simple, is pretty easy. All right, so yeah, the first one that we have is the displacement, right? So let's write down the three variables. So we have displacement s, okay, or sometimes in question they will use x also. Yeah, so it depends on which one, I mean, which is given in the question. But if based on the variable in Subat formula, then normally it's going to be it's normally denoted as s. All right, then we have the second one, which is velocity, okay, which is our v. After that, the last one is acceleration, so which is a. So in the previous lesson, we know that for us to get velocity function from the displacement function, we need to differentiate, right? So v is equal to ds dt. So similarly, to find acceleration from velocity, we need to integrate the function for velocity. oops, I'm sorry, dv. Yeah, okay, dv dt. So it's the same thing also if let's say I try to straight away come to here, then which means I'll need to differentiate two times for the for the displacement so that I can get my acceleration. Okay, now we understand that integration is basically the opposite operation of differentiation. So that's why if let's say we want to find acceleration from we want to find velocity from acceleration, which means that we will need to do integration. All right, so as simple as that. Okay, so if you want to have a more comprehensive idea, right, the idea is that when I try to integrate dv dt with respect to dt, right, is similar to when I try to integrate a with respect to dt. Am I right? Because a is basically dv dt. Okay, so by using the idea of differential equation that we have learned in P3, right, we know that for this one, since it's dt dt, so we can try to cancel off. So this is basically integrate 1 with respect to dv, am I right? Then equal to integrate a dt. So from here, then what do I get? So I integrate 1 with respect to v, so I get v. So it's equal to integrate a dt. So how do I get velocity? It's by integrate the acceleration function. Okay, so similar as this one. So when I try to integrate ds dt with respect to dt, it's the same thing when I integrate v with respect to t. Okay, so dt I can cancel off, then I left with integrate 1 ds equal to integrate v dt, right? So from here, then I integrate 1 with respect to s, then I have s, okay, which is equal to integrate v dt. All right, so that's the idea. So it means if you want to get v from s, then you're doing differentiation. Get a from v, integration. Differentiation. Then after that, from the other side to get v or s, then you need to do integration. All right, so let's try to look at the second concept here. Alright, so previously in our when we talk about displacement time graph and velocity time graph, right, we know that we can actually find the displacement of the object by finding the area under the graph, right? So for this case, it's very easy because what we are dealing with is basically constant acceleration. So that's why we will have a kind of like fixed shape. For example, it's either like a triangle or like in majority of the case, you will have things like trapezium and so on, right? So we can just use the formula to help us to get the idea. But the problem here is the situation that we are looking at now, right, is that the acceleration is not constant. So that's why if let's say the acceleration is not constant, right, for a velocity time graph, we will imagine that we'll actually have a curved graph rather than a straight line graph. So in that case, right, for example, if I'm having a graph like this, it's impossible for me to use like formula of the shape to actually help me to get my answer because this is eventually a curve, it's not a straight line. But from pure maths 1, we know that how to find the area under the graph is actually by using integration, am I right? So that's why if we know that, for example, the area under the graph for a velocity time graph is going to give me displacement. So that's why, how do I find the displacement or the area here? It's by doing integration, right? I integrate the function of the velocity here, then this is how I can get my s. So we are going to use this idea. So that's why similar to acceleration. So we don't have much like acceleration time graph, but eventually this is the same idea as how or why we can use integration to actually help us to find displacement and velocity out of acceleration and velocity. Okay, so yeah, so similar thing, we can apply this in our BT graph and also our AT graph. So a particle that moving in a straight line, so it's not more than it's not more than one dimensional, which means up, down, or like left, right. That's the idea. So for a particle that moving in a straight line, to find the expression for the displacement or velocity, we can use the indefinite integral. So which means s is equal to integrate v with respect to t. So if we want to find v, then it will be integrate a with respect to t. Okay, So if let's say we have, so this is what we explained just now. If let's say you want to find the displacement in a specific time, which means if let's say you are having a graph, perhaps something that looks like okay, maybe like this, yeah, how are you going to find the displacement change from here to here? So this is what we can try to use the definite integral to actually help us to solve that. So which means if let's say I'm given a time limit from t1 to t2, okay, so I can just use the formula, then is integrate v with respect to t, right? Because this is the function for the velocity. So it's from the lower limit t1 to the upper limit t2. So similarly, if I want to find v from acceleration time graph, then it will be integrate my a dt, then after that the from t1 to t2 as well. All right. So yeah, this is simple notes before we move on. Yeah, because we understand that when we try to find the expression, right? Because this is the part where we have indefinite integral, so that's why we will have the plus constant when you try to integrate it. So that's why normally you will need one, at least one information to actually help you to find the exact function. So in this case, right, we need to understand that for all the questions that we did, so yeah, for all the questions that we will be approaching later, the displacement will normally be if let's say the displacement are all measured from the initial position, so which means it tells us that when t equals to 0, s is basically 0, because the displacement start from the initial position, right? So this is the initial position, so meaning t equals to 0, then the displacement start measure here, so that's why s equals to 0. So that's the idea. Okay, this idea will be very helpful later. Okay, so now we'll be looking at four example here. So for the first example is going to be like uh, an example which I want to show you the difference of like different approach that you can try to use in this kind of question. Then number 2, 3, 4 will be like the partial question. All right, so let's start with the example. All right, let's start with example one. So as you go on, you'll realize that there's a lot of sub-question for number one. So it's like A, B, then we have C, D, E, F, then after that G, H, okay? So just bear in mind that this is not the kind of question that will like come out in your exams like this. So basically it's just like I try to put all the ideas about displacement inside this example. So I just want to show you different approach, and after that to understand what's the difference between them, so that when we move on to partial paper, then it will be easier for you. Okay, so yeah, it's not in this question we are not talking about like whether you answer A, then how are you going to use A to help you to answer B, then which one is shorter or which one is longer. Okay, so remember the idea is that we need to learn different approach here in this example. Okay, all right, so let's start with number one. So a particle move in the straight line so that its velocity at the time given is v equals to t to the power of 3 minus 5t squared. So A, find the expression for the displacement from the initial position at time t. All right, so for this question, we're going to find the expression for displacement. So we know that this is very direct. So we know that for us to find displacement, we will need to integrate the expression for velocity, right? Okay, so let's try to solve this first. So integrate t cubed minus 5t squared. So from here, then I'll be able to get T4 1 over 4 T4 minus 5 over 3 T3. Okay, I hope that you shouldn't have any problems with integration. So which means in the explanation itself, I wouldn't spend much time to talk about the integration skill or how do you solve the definite integration and so on. Okay, so and don't forget, because this is indefinite, so you need to plus C. All right, so now because the displacement is actually measured from the initial point at time t, right? So initial point is where you start. So where you start is your reference point. So that's why when your time is equal to 0, basically your s is also equal to 0. Okay, so by having this, then you'll be able to have 0 will be equal to 1 over 4, then 0, 4 minus 5 over 3, 0 cube plus c. So this is how we have c equals to 0. So from here, then remember to rewrite your expression. So s is equal to 1 over 4 t to the power of 4 minus 5 over 3 t cubed. Alright, so that will be your last answer. So I think this one is very straightforward. So yeah, I'm putting like this question for A because I want to use it to explain the relevance of the different approach in part B and so on. Okay, so let's try to look at B now. So find the displacement for the particle after 5 seconds. Alright, so this question is talking about displacement. So which means that we are not talking about how much distance this particle move. So that's why basically what we want to find for displacement is basically the s lah. Okay, so for this question, because A is soft, so that's why an easier approach is, just substitute it inside, right? So that's why the first approach that we can try to do is when t equals to 5, so we can just substitute. So s is equal to 1 over 4 5 power 4 minus 5 over 3 and then 5 to the power of 3. Alright, so from here then I'll be able to get my answer 625 over 4 minus 625 over 3, and this will give me my last answer is negative 52 1 over 12, and then this is meter. Alright, so this is obviously the easiest way to do it. Okay, now so we are going to talk about if let's say you actually didn't do part A, so which means that if let's say this question is given in a form of you don't have part A, then straight away you need to solve part B. Then is there any shortcut that you wouldn't need to go through this, then only go to your answer? Okay, so now you see we are finding the displacement for the particle after 5 seconds, right? So you remember in the notes part, we talk about if let's say you want to find the displacement or the velocity in the specific time within a time limit, then we can always use definite integral. Okay, so how can we apply it here? So which means that we want to find our s. Okay, so we want to find our displacement from time 0 to 5. So that's why when I try to solve integration, then it will be from 0 to 5 and then integrate with respect to t. Okay, or actually a much more relevant idea is that if let's say you can understand the idea for the differential equation, right, then which means actually we need to do for both sides, so which means this will be from 0 to s, which is the answer that you want. But in this case, then I don't want to confuse you guys so much on like the differential equation part, so that's why we can just assume that, which means that I want to find the change of displacement from 0 to 5. So that's what give me the displacement after 5 seconds, right? So which means that what I can solve is I can straight away 0, 5. So I put in my equation here. Okay, so I try to integrate and I'll be able to get the same thing here. So yeah, remember that I'm saying about if let's say you don't have part A, okay, then obviously if let's say you have part A in your question, then you can straight away just do this. So 0, 5. Alright, so now we can just substitute. So which means 5 power 4, 4 minus 5, 5, 3 divided by 3, and then minus 0. Okay, so from here then I'll be able to get my answer here as well, which is the same, which is negative 52 1 over 12 meter. Okay, so as you can see, actually this one combine your answer for part A and part B. If let's say you are not required to find the expression, so which means by doing this, then you can straight away get your answer that you get in part B. Alright, so that's the very useful application for definite integral. Then later we'll try to see another, like we try to see another aspect. Okay, let's try to look at C now. Okay, so now we are talking about find the distance traveled between t equals to 2 and t equals to 4. So you should realize that for C, D, E, F, they are basically quite similar. So C and E is asking about the distance, Okay, so there are different time frame here. So yeah, later I'll show you what's the difference. Then for the D part, we talk about the change in displacement. Okay, then the time frame is the same. So would you get a different answer from here, and how are you going to approach that? Okay, so you see, every time when we want to find the distance, right, we try to solve this together. So which means if let's say we want to solve the change in displacement, then it will be easier because why? I just need to come out what is the displacement here and what is the displacement here. Then I find the difference. Then I get the change in displacement. Am I right? Okay, but the problem is with the distance because for distance we need to get what is the total length that this particle travel. So between 2 and 4 we doesn't know that whether there is a change of direction or not. So the distance must, sorry, I wouldn't say must, the distance might be greater than the change in displacement. Okay, so now which means that to solve all these questions, the first thing that we need to do is to find out whether the particle change their direction or not. Okay, so how do we do that? So yeah, you should remember that when there is a change in direction, meaning that the particle will have a pause there, will eventually stop there. So that's why it's going to be v equals to 0, right? So I can just solve it. So from the question, we know that v is equal to t cubed minus 5t squared. Alright, so we need to solve when t cubed minus 5t squared. What is the t? Okay, so t squared, and I have t minus 5 equals to 0. So from here, then I will have my answer t equals to 0 and also 5. Okay, so by doing this right, then I know that definitely C and D is going to be easier than E and F. Why is that so? Because for C and D, right, because the turning point, the change of direction only happened at the 5th second. So that's why when I try to solve t equals to 2, between t equals to 2 and t equals to 4, there's no involve of change of direction. So my distance and my change in displacement is going to be the same, right? Because it's just like same direction. So that's why if this is 2 and this is 4, so which means the distance traveled and the change of in displacement is different. Okay, but for E and F is going to be harder because this is my 4 and then maybe this is my 6. But what happened here is that it involved things like change back. So which means that this is 4. I mean, I doesn't know that whether 6 will be much more in front or what not. Okay, but the idea is that it will involve a change in direction here. So which this is the 5 and this is the 6. Okay, so that's the difference between this. Okay, so now let's try to see how do we answer C first. Okay, so now let's try to do the approach so we can answer C and D together lah. Yeah, because we know that we are going to get the same answer, right? Okay, so the same thing, let's try to do the approach where you already got your answer from A. Okay, so I'll just write down the equation that we have. So S is equal to T 4 over 4 minus 5t cubed over 3. Okay, so the easier approach here is to just substitute. So I will have when t equals to 2, then I substitute s equal to 2 4 over 4 minus 5 2 3 over 3. Okay, so I can get negative and then 9 1 over 3. Alright, then continue. So I will get for t equals to 4. So s is equal to 4 power 4 divided by 4 minus 5 4 cubed. Okay, so from here then I'll be able to get negative for the 2 and then I will left with 2 over 3. Alright, so by having this then I can always find the difference, right? So for my answer, no matter it's for distance or is the change of displacement, I'm just going to get the same answer. Alright, so oh yeah, but then the only difference is the positive and negative. Yeah, I'm sorry for that, which means that you can straight away find these two, but then we'll need to be very careful on the positive and negative you have, because change in the displacement can be a negative number. Okay, so let's try to solve distance first perhaps. Okay, so for distance, then it will be quite easy lah. So if let's say you don't want to think about it, then you just use the the displacement for the final stage minus the initial stage, and you need to do a modulus lah basically. So 2 over 3 minus negative 9 1 over 3. Okay, so from here then I'll be able to get 33 and then 1 over 3. Alright, so that's the distance part. Alright, but for the change in displacement, so for change in displacement, we need to know whether it moved to the negative or the positive, right? So that's why for change in displacement, we'll use because when we talk about displacement, we talk about what is the change with refer to the reference point. So for this part, the reference point is basically your t equals to 2. So that's why we will try to use this number. Okay, so the same thing here. So negative 42, 2 over 3 minus 9 1 over 3. Okay, and this answer will be a negative answer, because eventually compared to your t equals to 2 and t equals to 4 is going to be much more negative. Okay, so that's the idea. So which means for this case, right, if we try to look at graph approach, so this is t cubed minus 5t squared. So you will know that you will have a intersection point with the x-axis at t equals to 0 and t equals to 5. So basically, if you have like a VT graph, right, how is that going to look like is it will eventually goes down first because it starts from 0 0, right? So it will be something like this, that it moves up. Yeah, so because this is a cubic graph, I'm sorry, I should draw it like much more smoother. So okay, yeah, so but basically that's the idea lah. So this is the part that it come out, this is the 0, and then this will be your 5. So which means that what you're finding here is 2 4, which is here. So that's why your answer, so why do I know that it goes down first? Because I know that from my answer for B, so meaning after 5 seconds I'm getting a negative answer, and between 2 and 4 it gives me a change in displacement for negative 1 as well. So that's why I know that for the initial part, right, the V is moving to the negative direction first, then after that only come back when t equals to 5. So that's why this is how the graph will look like, and what you are finding is basically 2 to 4 here. So that's why to get a negative answer is correct, because it's basically below your x-axis. Okay, so now we try to look at the D part. Sorry, to try to look at the E part. Oh, I'm sorry. I want to show you another approach over here. Okay, so let me try to do it here maybe. Yeah, this is all for C and D. This is continue one, yeah. Okay, so another approach to solve this is the same thing, which means if let's say without part A, then how can we do it in a much more shorter way? Okay, so same thing, because we are finding the limit from 2 to 4. So that's why how we can solve it is by doing the definite integral as well. So which means I can always find it. So let me try to do the C first. Okay, because this is the distance, right? Okay, so that's why we know that all of it is actually under the same region, so which means it's the negative region. So that's why in this case, I wouldn't need to split them into 2, right? Because it's all under them. For me to get the distance is basically just negative my answer here, which will be a negative answer. So that's why for me to find my distance, it's just basically equal to, if then I need to integrate my v with respect to t, right? So the distance traveled is from 2 to 4. Okay, then after that you'll kind of solve it up, then you will see that the idea is just the same thing, because when you integrate v, then you substitute, then this is what you get, right? Yeah, so this is the 2 and 4, this is what you get. But if let's say this question you didn't have part A, which means you do not have this, then meaning that you can straight away do this in this integration rather than like do it to find expression, then after that do this. So that's the idea. So by having this, then you can imagine that your answer will be definitely going to be a negative answer this because of what you are solving is a negative area. So that's why for you to get the distance, we know that distance must be greater than 0. Then you just write your answer, negative your answer lah. Or from here, you can straight away try to do modulus also can. So this is the approach for C. Okay, so for D, right, then which means that you don't need to do anything lah. Basically, it's just the same thing. So which means the change in displacement will be just equal to from 2 to 4, then V dt. Okay, then you'll be able to get your answer already. So you should be able to get the exact same answer like what you get here. Okay, so now let's try to look at E and F. So I'm going to show you two approaches as well and to show you the difference of it. Okay, so the first one, which means it will be the similar like how we solve this, right? Okay, so same thing, let's try to substitute. So S will be equal to T4 over 4 minus 5T cubed over 3. Okay, so now let's try to see this. I'm not going to do the substitution part because it seems that I might do not have enough space here. So we can straight away write down the answer perhaps. So when T equals to 4, all right, then I will actually have S will be equal to negative 36. So by substitute also the same thing here. So when T equals to 6, then I will be having S is equal to negative 42 2 over 3. Okay, so you see that this is definitely further from the reference point, but it doesn't mean that it's from negative 36, then after that go there, then stop. Okay, because there is a change in direction, so which means it's negative 36, then it goes further than here, then after that it comes back. So that's why the last point here is still further than this point. Okay, so this is the idea for 4. T equals to 4, T equals to 5, and T equals to 6 from the number that we got here. So what's the problem here? Yeah, the problem here is that we doesn't have 5, right? So that's why in this question, we might need to find out what is T equals to 5 as well. So that's why in this case, when T equals to 5, our S will actually equal to negative 52 1 over 12. So by having this, then it proves that your assumption is correct because you see this one is the furthest point, then after that it come back, right? Okay, so if let's say you are solving the question for F, right, then which means you doesn't need to do this part. With 4 and 6, then you just minus. Okay, but if let's say you are doing the distance also, so which means this matters. So which means if let's say you didn't do your 5, then basically your distance travel is going to be wrong. Okay, so same thing here. Let's try to find the distance travel here first. Okay, so what's the distance travel? It will be from here to here, then after that come back, right? So that's why you need to find the difference between here to here first. Okay, so same thing, we can try to use modulus. So negative 52 1 over 12 minus negative 36. Okay, and the other distance will be from here to here. So that's why plus negative 42 2 over 3 and then minus 52 1 over 12. So this one no need modulus also come out because it's a positive one. All right. So from here, then I'll be able to get 9 5 over 12 plus 16 1 over 12. I'm sorry, I think so this should be here, this should be here. All right, then from here, then I'll be able to get 25 1 over 12. Okay, so this is for distance. Okay, so now same thing. Let's try to find the change in the displacement. Okay, so for change in displacement, which means that we doesn't care about, how much it travel, right? So we only take the last one, the last position to minus the previous one. Okay, so this is how we'll get to our answer is 6 2 over 3 meter. Okay, so which means when t equals to 4 is here, then your t equals to 6 is here. So negative. Okay, so that's why the change in displacement here is going to be this distance only. So that's why it's much more smaller than the distance traveled, and you have the positive to indicate that it's more towards the negative side. Okay, so now we try to solve it by using the definite. Okay, so similar thing. The question that I want to ask you is that do you think there's a difference when you try to solve distance or change in displacement by using definite integral? So we know that for this question, right, we can straight away it's the same thing. I mean, the only different things is that the positive and negative sign, but for the integral part, there's no difference. Am I right? Okay, but for this one, is there any difference? Okay, so you might want to pause and after that think about it and see. Okay, so for E, right, we are doing the distance travel. So go back to the properties of the area under the curve. If you still remember, right, if let's say we want to find all the area here and all the area here, what do we need to do? We need to actually solve for the below part, then after that plus for the above part, right? Because if not, then our answer will be the combined answer when they plus this area together and this area. But the problem is that when we try to do integration, this definitely going to give us negative answer. So when you have this answer then plus this answer, the answer that you get, it will be much more smaller. So that's why for this question, for you to answer E by using definite integral, then what do you need to do is you need to split them into two. Okay, let me try to do this. So this is your 2 and 4. So that's why I'm just going to draw here. So maybe this is the 6. Okay, so you can realize here is what you want to find here is the distance from 4 to 5, which means is here. And after that, from 5 to 6, which is here. So I want to find the total distance from 4 to 6. So if let's say I combine them together, right, then this answer is going to be, plus is going to be minus this area here lah, because this is going to give us negative in integration. So that's why they will straight away give you the change in displacement. If let's say you want to find the distance traveled, which means we need to separate it. So which means the first one will be S is equal to, I have my first one, which is 4 over 5, 4 to 5 v dt, which is for this place. And I know that it's going to give me a negative answer, so I can straight away modulus it. Okay, after that, the second one, then it will be from 5 to 6. So please remember that although there's a properties that you can combine them together, but you can't do that here. Because when you combine, then meaning that the area that you are going to get is going to be the sum of these two numbers already, which is, because this number is negative number, I hope that when you plus them together, it's not equal to when you plus two positive number together, okay? So the number that you get will be smaller already. Okay, so when you have this, then meaning that you will need to solve for when you substitute 4 and 5 inside lah. So let me just try to quickly write down here. So I will have my Vt here, which is T4 over 4 minus T5 cubed over 3. Okay, then substitute 4, 5. Again, this is the approach where if let's say you do not have part A, okay, so plus T4 over 4 minus, yeah, this one no modulus. Sorry. Okay, so from here then I can have 5, then 5 to 6. Alright, so now we can straight away, this is the modulus. Alright, then you can just substitute and you'll be able to get here is, you can straight away get the number that you have here. So when you substitute 5, then you'll be able to get negative 625 minus negative 128. Okay, and then after that modulus your answer, then plus the other part, we will have negative 36 minus negative 625 over 12. Okay, So from here, when you try to solve it, then you'll be able to get 25 1 over 2 as well. Okay? 1 over, yeah, perhaps we can try to write down that one. So 9 5 over 12 plus 16 1 over 12. So which will give me the same thing as you get in the previous approach, which is this one. Okay, so now the last part. Do you think for the change in displacement, do we need to split that up? No, right? Because eventually I just want to get the difference. So that's why this answer is possibly to be a negative number. So yeah, fine. I mean, for the real picture here, the area under this is going to be larger than this one. So this is why we get a negative answer, right? Okay, so the idea is for change in displacement, you do not need to split them into two because you are not going to, I mean, the idea is you are not going to get here and then after here, then after that you solve it, right? So for change in displacement, basically we only get 2 points and we get our answer. So that's why you can straight away just substitute your your 4 and 6 inside here. So meaning for F, then the S will eventually be equal to modulus. Sorry, this one you do not need the modulus. Yeah, because eventually you need the positive or negative. So from 4 to 6. Okay, so from here then you'll be able to solve VT. Alright, so it's the same thing. I don't continue here. So basically your answer, you'll get the same thing like what you get above. Okay, so I hope that you can understand the idea for the definite integral. Okay, so now let's continue with the next part. So the last part for number 1. So we have G and H. So G, work out the distance that the particle travels in the first 10 seconds. Okay, so this is the questions that regarding to the distance as well. So that's why like what we said, so to know that when the particle change direction is important. So since we already did in the previous part, we are not going to repeat that. So let me just write it down. So V is equal to T, yeah. Write down the important information here so it will be easier for us. T 4 over 4 minus 5T cubed. Okay, and when V equals to 0, we know that the change in direction basically happen when 0 and and 5. Okay, so that's why when I try to find the first 10 seconds, then I will be able to know that if let's say I were to substitute, right, then which means that I will need 3 value lah. So the first one is going to be when my t equals to 0. Okay, then my s will be equal to, so you can just substitute, then I can get 0. Okay, then the same thing when t equals to 5, then I know that I should be able to get 5 4 over 4 minus 5 4 5 5, I'm sorry, 3 over 3. So I'll be able to get negative 52 1 over 12. So it's the same thing like what we get for the CDF just now. Okay, so same thing here. Then I would want to find t equals to 10 also. So I don't write here already. So I can get 8 3 3 1 over 3. So that's why for me to get my total, then I might need to make sure that I understand how it moves, right? Okay, so for this one, it started from 0. Then after that, it moved to negative 52 1 over 2. So that's why the first is 52 1 over 12. Then after that, this is negative, right? Then it passes through 0, then go to the positive side. So that's why the second one is go and then come back. So which means, okay, yeah, because just now we try to, or I think we try to draw like as if the negative is towards the right hand side. So that's why I would just use the same thing here. So which means it's negative here. Then after that, it goes so positive here. So I have here as initial, it goes to the negative side, then it goes to the positive side. So that's why when I try to calculate the distance, then it will be here, then come back here, right? So it's another 52 1 over 12, and then plus the last distance is 833 1 over 3. Okay, and they'll give me my answer 39371 over 2. Okay, so please remember that if you are doing definite and definite integral, so it's the similar thing like what we explained by using the area under the graph just now. So you should actually split them into two, okay? Because if not, then your answer will be deducted each other. So that's why S can be solved by equal to from 0 to 5, because we already know that's the change, that's the change of that's the change in the direction for velocity, the direction for your particle here. Okay, so this one you should have modulus because we know it's area under the x-axis. So as well as 0, 5, then Vt. Okay, then after that plus another one which is positive one, which is from 5 to 10. Okay, so same thing. I'm not going to repeat to write here, but basically the idea is that you have t 4 over 4 minus 5t cubed over 3, then substitute 0, 5. So similar thing for here. So we have t 4 over 4 minus, okay, then you substitute 5 and 10. All right. So from here, then you can imagine that when you substitute 5, right, then you are going to get this number. Then when you substitute 0, then you are going to get this number. Okay, the last part, when you are going to substitute, then I get 8331 over 3. Then after that, minus, then the second one is negative 52, then 1 over 12. Okay, so you can imagine that at the end, you're still going to get the same thing now, because modulus of this, you're getting this number, right? Then when you try to use this number plus this number, then isn't it? It's just basically this part. So it's 9371 over 2. Okay, but the idea is that you need to imagine, if let's say you are not given A, then which means your approach or the method that you choose to do like this is eventually longer, because you need to get the expression for that first. But if let's say you are using the definite integral here, which means you do not actually need to find what is the expression for S, then you can straight away get your answer already. But yeah, both answer, there's nothing wrong when you use both, but it's just that which one is longer, which one is shorter only. Okay, especially in later past year question, you will see, I mean, this is very useful, like the shortcut that we have here. Okay, so a note here is it must remember that you cannot do S equal to from 0 to 10, because if you are doing that, then meaning you are finding the change of displacement only. So remember that you cannot do this. All right. Okay, then for the last part, find out the time when the particle returned to the initial position. So which means we need to solve when S equals to 0, then what is our T? Okay, so I guess this should be easy. So H, all right, so for this one, when S equals to 0, so this is mean it returns to the original position. So we need to solve T4 over 4 minus 5t3 over 3 equals to 0. Alright, so we can just multiply 12, I think. So 3t4 minus 20t3 equals to 0. So I take out t3. So I have t2 minus 20. Okay, so from here, then I can get it will be t equals to 0 and also 20, so 6 and then 2 over 3 seconds. Okay, so yeah, for H is just like that. So I hope that by using this different question here, it will show you like how do you use different approach, then when is the time that you need to split your integral and when is the time that you doesn't need to do so. So basically what you must be very careful of is that whether the question is asking you about the displacement or is asking you about the distance. So if for displacement, then which means you wouldn't care about whether the direction change and so on. So basically, just by using integration, by using definite integral, it will help you to get the answer. So a problem is if let's say it involves the distance, so which means that we might need to find what is the change of, or is there any change of direction involved? So if there is, so meaning that we need to split the integral. Okay, so that's the idea. All right, so now let's try to look at the past year question 2, 3, 4.